All right. Here we go. All right. Today we're looking at comparing functions, linear and exponentials. Okay, we'll spend a lot of good time on this on Monday. This is 2.6.1 and 2.6.2. All right. And actually, I should change that so it's 2.6.1 and 2.6.2. All right. So looking at this, first of all, when we are comparing graphs, we can do it in a few different ways. We can compare based on the rate of change, which is our slope, right? Because if I have two graphs, like so, if I have two graphs on this here, all right, tell me in the chat, red or green, which graph is increasing faster? Which graph is increasing faster? Think of it like a plane flying up into the sky. Good, good. Increasing faster. All right. Looks like we got about 99% that are saying green. And that is right, because look, this is increasing faster. It's going up into the air faster. As far as time intervals, by 2, it's already way higher than the red. By 3, it's going to be way higher than the red. So the green graph is increasing faster. That's one way to describe it. I could also say that the red graph, the Y-intercept, is greater. Right? That's another way to compare it. The Y-intercept right here where it crosses the Y-axis is greater, because down here is where the green graph crosses the Y-axis. Okay. So we have a couple things we're going to describe. We're basically going to be comparing the graphs with slope and with the X and Y intercepts, which we'll get to. But looking up here, where are we going to compare it? Right? Where are we going to compare it? Oh no, gotcha, Curtis. No worries. All right, so we're going to compare it along a certain interval, okay? Along a certain interval. Now, the interval is just going to be the domain. It's going to be an x values, the x values that are included, right? So for instance, the interval of 2, 4, this is always going to be talking about our domain, our x values. So when I have the lower is 2, the upper is 4, I'm looking at the interval between 2 and 4. I'm looking to see what's going on between 2 and 4. It's almost like when we were cropping out, the squirrel, the photobombs that we did, that one Desmos activity. We were saying, well, what do we want to look at? With the interval, it's saying you can only look at 4 as the upper limit and 2 as the lower limit. It's just telling you where exactly you're cropping your picture and where you're going to look, okay? Where you're going to look. So if I said this, if I said, compare along the interval 0, 1. Hard brackets mean that we are including that value in it. So I would look here and I would be looking to see what's happening between 0 and 1. Right? What's happening between 0 and 1? And I would have ways to describe that. I could say that, I could say that the red graph, which is this graph here, the red graph starts with a higher value, right? Starts with a higher value. When time is 0, it starts with a higher value. That would be one element that I could talk about. I could talk about the slope like we did. We could talk about where they intersect. That might be important sometimes. Okay. So when I'm talking about the interval, another thing, and this is key, x values are time values. Okay. So that's how we're basically looking at this all the time. This is 1 unit of time, 2, 3, 4 units of time. So what it's saying is, if you threw a football, it's going to fly in a parabola. And if you said, tell me what's going on at the parabola between 3 and 4, it's saying, well, here's the flight of the ball. It's saying what's happening right here between the seconds of 3 and 4. Okay, it's just narrowing where you're looking at. That's what the interval does, and then you have to assess it in there, in that little area. So give me a thumbs up if you've done the slope before. If you feel pretty good with slope, given 2 points, if you get 2 points finding the slope, we've seen that before a little bit. Okay, so we're going to be looking at the slope, and I'll tell you that the slope, if we're given this interval, the slope is going to be between these 2 points. I'm going to say this is 2. So the slope is going to be between these 2 points. So we'd have 2, 1, right? That's what this point is. We over here would have, I'm going to just miff it a little bit. There. We'd have 4, 2, approximately, right? And that would be the 2 points that we use in order to find the slope between those 2 points. Okay? So the interval breaks the equation down, or the function down, to a smaller window, and then we look to see what points are on the edge of those windows, and we see the slope between those 2 points. Okay. So let's see if we can look at a problem right now. Oh, I'll say the other thing here. When you're assessing the Y-intercept, what you're really assessing is what is going on when time is 4, 3, 2, 1, 0. When time is 0, you're on your Y-intercept, your Y-axis. So its graph hits the Y-axis when time is 0. When time is 0, 4, 3, 2, 1, 0, we're on the Y-axis. So the Y-intercept is what's going on when time is 0. The X-intercept, the graph hits the X-axis when the value counted is 0. So if I added another line here, and I was like this. First of all, this is decreasing. It's going downhill. And this value right here, what it says is, here it's up here at, 2, 1, 0. If I was counting bunnies or money, this was money. When it crosses the x-axis, that's when your money is 0. So graph hits the x-axis when the value counted is 0. Remember, we're counting, this is time in general. This is money. So this would be, you're losing money, you're spending it on your vacation, and after 2.5 days, you don't have any money left. You have $0 left. Okay? That's actually the big idea. I want to do 2 example problems, and I think that you'll see what you have to accomplish. The problems today are all very, very similar. So let's look at one of these and see where we're at. Okay. So I'll give you time for this to take a screenshot after. Sorry for the pace, but let's keep it going. All right. So for number 8, here's what we have to do. Instead of having graphs already written or drawn, we have one graph, which we can assess, and we have a table of values X and Y. Okay. So here's what you can do. You know what I would do? Because this is your workbook, I'm going to do it as if I'm able to write in the book. I'm going to use pencil. So here's the thing. Function B shows the remaining balance in dollars of the cost of car repairs after X months. So look, after 12 months and change, you don't have any more money to pay for your car. After 1 month, you still have about, $1,480. After 10 months, you have about $300 left, but after a year and change, you don't have any money left. Okay. So here is one of the functions. Here's the other function. This table shows the remaining balance of cost of car repairs after X months. These are different. These are totally different. This is not this exact graph. Okay. This is not this graph. What I would suggest in the workbook is taking these table values and recognize that these are just points. So since those are just points, I can go in here and I could graph them. Watch. 0, 1,560. 0, 1,560. Right about there. 1, 1,430. 1, 1,430. 2, 1,300. 2, 1,300. 3, 1,170. 1,170. 70. So look at that. I actually already got my graph, and it looks pretty much like it looks pretty parallel. Let's see. So you see, I graphed the table. Here. Right? Now let's look at this. We are going to compare the functions. So I want to look at this and say, well, how do I find this slope? y2 minus y1, rise over the run. You could try to put this to memory if you don't have it yet. So here's the thing. These are linear equations. So we aren't given an interval for this one. I think the intervals are actually in the next section. But here we are given some points, and we're given a graph. So for one, I'm going to do this for the table. Because I know that this is an x, that's a y, that's an x, that's a y, that's an x, that's a y, that's an x, that's a y. So I only have to pick two points, and find the slope between them. I'm going to pick these two. Because 0 is easy to deal with. Okay. Now, when you have these 2 points, you're going to go ahead and identify them, x1, y1, x2, y2. All right. And then plug them in. Let's see, y sub 2, I've already labeled them so I could trust it. 1430 minus y1, 1560, over x sub 2 is 1 minus x sub 1 is 0. Man, that works out. When you use 0 and 1, look how quick it's going to work out. So it looks like this is negative on the top, 1430 minus 1560. You can do that on the calculator. You get negative 130. It's going to be over 1. 1 minus 0 is 1, so we got the slope for the first one. All right. All I did, these are points, so I took 2 points and I labeled them x1, y1, x2, y2, put it in my slope formula, worked it out, got the slope. Now from a graph you got to look a little closer, but this is going to be the same process for exponentials. So I'm going to show this linear, and you know what? After this, I'll record another video on exponentials. I'll be able to get to it next period, so I'll add that to the stream. You can check it out. Now look, we want to pick on the dark graph here. We want to pick some points that are really close to being right on it, like this one. You see how that's right on a point? So I'm going to pick 2 points that match perfectly to some of my grid lines here. Let's see. Here. All right. So this point is at 700. This point is at 10, 300. All right. Same process. x1, y1, x2, y2. Throw it into our equation. So we're going to put that right here. Let's see, y sub 2, 300, minus y sub 1, 700, over x sub 2, 10, minus x sub 1, 7. Right. So what are we going to get? We're going to get on the top negative, so 300 minus 700 is negative 400. On the bottom, 10 minus 7 is 3. And who has that in the chat? Jessica, what is that? Let me see if I can do it. Oh, that's not that bad. Negative 133. You know, 0.3, but we'll keep it as that. Okay. So look what we have. We have 2 different slope values. So if I'm comparing these guys, I would say that function 1, or I might say function 1 has a greater slope than function B. So function A has a greater slope than function B, just because negative 30 is a larger number than negative 133. Sorry, negative 130 is a larger number than negative 133. Basically, you're going to get your 2 slopes and then just compare them and write a sentence that kind of describes the 2. You could also say that function A starts with a lower value than function B. All right. So this is a little bit tricky, but I want you to at least get to this step. If you at least get your slopes, that is good. I want you to shoot for that for Monday. Try to just get your slopes, okay? I'll put another video later today on exponentials. I want you to try to find your slopes and then try to make a sentence that compares it. What is it saying? Okay. That is all the time we have for today. I would actually just say that by Monday, try to get through the first section, getting the slopes. Okay. So you have sections 261, whoops, 261, and you also have 262. So try to get through 261. That's the linears. 262 are exponentials. We'll look at that one on Monday. We'll probably slow down this a little bit, so I'll change the due date for this. All right. Sorry it's so late, guys. Sorry it's so late. 2 minutes over. Enjoy your lunch, and I will see you on Monday, okay? Stick around if you have questions. All right. All right. Sienna, do you have a question?